Happy Sunday to you. I've got my nice cup of coffee here, my comfy shirt on, and 4 modules that I would like for us to try to knock out today. The first of which is Chapter 4, Module 3, Powers of Monomials. Content objective says students will use laws of exponents to find the powers of monomials, and the suggested pacing says this should be a simple one-day lesson. We shall see how accurate they are. Murals are pieces of artwork that are painted or applied to a permanent surface like a wall or a ceiling. Murals are usually very large, with one of the largest covering more than 250,000 square feet. The mural at a local school is in the shape of a square and has side lengths of 5x cubed feet. Now really, what school is going to write it as that? I know you're thinking this is stupid. I'm thinking this is stupid, but let's pretend it's not stupid. What does the expression 5x cubed represent? Do you think it is equivalent to 5x cubed times 5x cubed? Explain your answer. These are the things we're going to learn when we cover this lesson. So how can you simplify a power raised to another power? That is our inquiry question. That is what we're trying to figure out. The Marine Club at Westville Middle School purchased an aquarium. The aquarium is in the shape of a cube, with the side lengths being 2 to the 4th inches, because that's how normal people measure side lengths of aquariums. Now we're going to watch the animation to see how we can determine the volume of the aquarium.
The Marine Club at Westview Middle School purchased an aquarium in the shape of a cube. Each side of the aquarium has a length of 2 to the 4th inches. The students want to know how much water the aquarium will hold. To determine this, they will need to calculate its volume. In the formula, V represents the volume and S represents the length of one side of the cube. Since the side of the aquarium has a length of 2 to the 4th inches, let's substitute this value for S in the formula. The formula now has a power, 2 to the 4th, raised to another power, the 3rd. How do we simplify this expression?
Well, they laid it out nicely for us, but they didn't really teach us anything other than the fact we could substitute the side length in for S into that formula. So let's get into it and figure out exactly what we're supposed to do. The volume of the aquarium can be represented by V equals 2 to the 4th cubed, just like the video showed. What does 2 to the 4th represent? Well, that represents the length of one side of the aquarium. And the exponent 3 tells you that you have to take that base, 2 to the 4th, and use it 3 times. So what are we going to do? How are we going to work through this problem? And I think you're going to find this is really darn simple. You could expand this out to end up being 2 to the 4th times 2 to the 4th times 2 to the 4th. And we have already learned in our lessons, I think it was yesterday or the day before, that when you have a common base, you leave the base alone and you add the exponents. So instead of writing it as 2 to the 4th times 2 to the 4th times 2 to the 4th, we could simply take and say that, well, that is equal to the 2 to the 12th right here. Now I'm going to take a real quick side trip, and I'm going to say, what is 4 times 3? Oh, my kid changed the size of my mouse. Hold on. Alright, maybe now you can see the mouse here where I was pointing 4 times 3 and 12 and all that happy stuff. Let's keep going as we continue to learn how this works. Now the textbook wants you to take and make a conjecture about how you could simplify a power raised to another power. So based off of what I just showed you, what do you think it's going to be? I'm thinking that we could take the power and multiply it by the other power, and they say to simplify a power raised to another power, multiply the exponents. That's all you have to do. So let's take a look at these other examples they've given us here. You've got 3 squared raised to the 5th power. That's 3 squared times 3 squared times 3 squared times 3 squared times 3 squared. And if you were to take and do that using the way I taught you before, you would do 3 squared plus 2 plus 2 plus 2 plus 2, which is also equal to 10. And 2 times 5 is 10. The same exact thing will happen with the 4 to the 9th cube and with 5 squared cubed. It's all going to work out the same exact way every single time. Alright, enough playing around. Now it is time to actually get in here and learn how to use the power of a power rule, which, by the way, is a vocabulary term you're going to have on your upcoming vocab quiz. It says you can use a rule for finding the product of powers to illustrate how to find the power of powers. And we're going to move through the steps and see what happens. So right here you've got 6 to the 4th cubed, which is 6 to the 4th times 6 to the 4th times 6 to the 4th 3 times. Next, you would do 6 to the 4th plus 4, also known as 6 to the 12th. That would be the way we would do it if we were using the product of powers rule that we were used to use. But now we can also use the power of a power rule. Let's go ahead and highlight that part right there because that's going to be kind of important. And take that on to our last slide. And it says, if you notice, the product of the original exponents 4 and 3 is going to be your final power. And that lays the foundation for what's next to come. And so we have the power of a power property, and I've highlighted the term in green, but the actual definition is going to be down here in our flip charts. Let me go down, get them all loading, and the definition would be to find the power of a power, multiply the exponents. That's what you're going to find on your vocab quiz for the power of a power. If you look at it algebraically, a to the m raised to the nth power is going to be a to the m times n. And if we were to look at it with numbers, that would be 5 squared times 3 is equal, excuse me, I'm sorry, 5 squared and then cubed is the same thing as saying 5 squared times 3, also known as 5 to the 6th. Easy math any way you look at it. I do need to make sure you understand though, this right here, that is going to be showing your work. If you do not show me this on every one of these problems of your homework, justifying how you got from the problem to the answer, I am going to be taking points off of for you. So now that we have explained it, let's actually start putting it to some numbers. Here we have 8 to the 6th raised again to the 3rd. And they want to know how can the power of a power help you simplify? All you have to do is multiply the 6 times the 3. So my very next slide is going to say to write your original expression, just like I've told you to do. Next, showing your work, you're going to be using the power of a power property. You must include this in your supporting work, 8 to the 6th times 3, and then that's going to go on to your final answer, 8 to the 18th. And if you wanted to type that 8 to the 18th in there, go ahead. I'm not going to because they give it to us right here. So 8 to the 18th is going to be our final answer on that. And this is going to be showing your work. Your original problem, your supporting work, your answer. It really is that simple. Now your book is asking you to describe a method you could use to check the solution. Well, that method is going to be the product of a power rule that we learned a couple of days ago. The product of a power is a perfect way to check your answer in a power to a power rule. And now it's going to be your turn. Take a moment, pause the video, and solve the problem that will hopefully load soon on my pitifully slow home internet. There it is. Do that problem, submit your answer. Alright, so our problem says to simplify 2 to the 5th, which is then again cubed. Now, once again, the word simplify, it's not solve. We're not going for a final answer in standard form. It wants us to write this using as few numbers as possible. So all we have to do for this, turn on my little pen here, is we're going to rewrite this as, of course we need to have a marker, put in your equal sign. So I'm going to have my next step is going to be 2 to the 5th times 3, which is equal to 2 to the 15th, which is going to be the final answer. I'm going to jump back over here to my answer key. I'm going to type in 2 exponent 1, 5, accept and check, and the answer checks that easy. It's easy math, isn't it? So what's going to kill you on these things? Remembering when to use a product of a power. You use that when adding, and using the power of a power, which you use when multiplying. So you have to be able to recognize which one comes where, and that's what's going to end up hurting you on the test. This stuff's really simple, but if you're not going back and reviewing it, you're going to get choked up on the test and not remember which one to use when. Here I have k to the 7th power raised again to the 5th power. So they wrote the original problem. Next they're going to do k to the 7th times 5. 7 times 5 is 35. That's your final answer, and if it makes your heart feel warm and fuzzy, you can go ahead and put it right here in the answer key. Now it's going to be your turn again. Go ahead and solve this problem. Pause the video while you work on it, and while you're doing that, I'm going to be getting a screenshot of it, and I'm going to go ahead and work it on my own. Did you pick your right answer? Let's see what I end up getting. So I'm going to take w to the 4th power raised to the 6th power is equal to w to the 4th times 6 using the power of a power rule, and that's going to equal to, of course, 4 times 6 is 24. W to the 24th power is going to be my final answer, and all of this is going to be showing my work. If I don't have that on each and every problem of the homework, I know that I'm going to be doing it just for fun. Jump back over to our problem, and we're looking for w to the 24th, which is D, and our answer checks. Really is that simple. But what if we have a power of a product? It really is no more complicated than what we've done before. Now we've got 4 times a squared, and then from there, all of that is going to end up being cubed. So we're going to take and we're going to use the, before we're going to expand them out yet, you've got 3 factors here of 4a squared times 4a squared times 4a squared. Now this is not how you're going to show your work. This is explaining how it works. So from there, you could see that using your commutative property and your associative property, commutative property says order does not matter when multiplying. Your associative property says that grouping does not matter when multiplying. So they grouped your constants, that's your 4's, and your variables, which is a squareds, into different sections. From there, how many 4's do you have? You've got 3 4's. How many a squareds do you have? You have 3a squareds, and then on that a squared you have a power of a power going on. So from that, all we have to do is take and do 4 cubed. That's 4 times 4 is 64 times, 16, and then 16 times 4 is 64. And then next you have a squared times 3, which is a to the 6th. So your final answer will be 64, a to the 6th. Now this is not how we're showing our work. This is explaining how the answer would work. It says notice that the factor inside the parentheses is going to be raised to a 3rd power. So everything that's inside your original parentheses, all of that gets multiplied by itself 3 times. Now this looks like a good place to end part 1 of this lesson. When we come back, we're going to work on defining the power of a product property and doing some practice problems involving it.